Hello everyone, in this video we're going to explore top 4 logistic growth MCQs that most tested on the AP Calculus PC exam. In AP Calculus, the exponential growth model was derived from the fact that the rate of change of a variable is directly proportional to the value of y. When using the differential equation, dy over dx equals k times y, and its general solution y equals c times e raised to the kt. You may notice that the exponential growth is unlimited. However, when describing a population that often exceeds an upper limit L, past which growth cannot occur. This upper limit L is called the carrying capacity. It represents the maximum population y of t that can be sustained as time t increases. A model that depicts this type of growth is called a logistic differential equation. dy over dt equals k times y times 1 minus y over L, where k and L are positive constants. The logistic differential equation of the form dy over dt equals k times y times 1 minus y over L results in a solution of the form y equals L over 1 plus b times e raised to the negative k times t. Alright, so we have the formula logistic differential equation form is going to be this one, and logistic growth equation form is going to be this one. In either form, L represents the carrying capacity right here, L right here, and L right here should be the same, or upper limit of the logistic growth equation, which is the maximum. Alright. A logistic growth curve increases the fastest when the curve reaches half its carrying capacity L. Now let's move on to question 11. The number of moose in a national park is modeled by the function m that satisfies the logistic differential equation dm over dt equals 0.6 m times 1 minus m over 200, where t is the time in years, and m of 0 equals 50. What is the limit of m of t when t approaches infinity? So when t approaches infinity, this guy approaches L, which is carrying capacity. Carrying capacity is right here, 200. Right? The answer must be B. Now let's move on to question 12. Which of the following differential equations for a population P could model the logistic growth shown in the figure above? Alright, so observe that this figure has the carrying capacity 200, right? Now remember, we have the differential equation of a logistic growth model given by dy over dt equals k times y times 1 minus y over L, where L is the carrying capacity. Now look at the answer choice right here. Y in this situation is P, right? So I just replace Y with P, right? So I have dP over dt equals K times P times 1 minus P over L, right? Now I'm going to expand this one, so it could be dP over dt equals Kp minus K over L times P squared, right? So this formula, we're going to come up with a conclusion. A correct logistic equation must have a positive linear terms Kp, right? This guy positive. A negative quadratic term, this one is negative right here, right? And level of at the carrying capacity L right here, right? So we look at the answer choice right here. We need to eliminate C, D, and E because they all have the positive quadratic term, right? Now for the first one, we need to factor P out. So we have 0.2 minus 0.001 P, right? So we're going to set this one equal to 0, right? So we have 0.2 minus 0.001 P. So it's going to be P equals 200, right? Which is the maximum value right here, right? So the answer is A. Now look at answer choice B. We factor P out, right? So we only end up with 0.1 minus 0.001 P. Set this one equals 0. So P equals 100, which is not the right one, right? So answer choice B is wrong. Now let's move on to question 13. Let K be a positive constant. Which of the following is a logistic differential equation? We know that the logistic differential equation is given by the formula dy over dt equals k times y times 1 minus y divided by L, right? So we look at the answer choice right here, only E correct, right? So this problem very simple, you just recognize the logistic differential equation, right? Now let's move on to question 14. The number of fish in a lake is modeled by the function p that satisfies the differential equation dp over dt equals 0.003 p times 1000 minus p, where t is the time in years. Which of the following could be the graph of y equals p of t, right? So basically, you just recognize the logistic growth differential equation. That's it, right? So actually, answer choice is A. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.